Alright guys, so the next set of problems we're going to talk about are, we like to call them rate in, rate out problems. So this one is an FRQ that was on a recent AP exam, kind of broken down like we did yesterday. So it says, when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display at a rate modeled by this F of T. Now, it's a complicated equation. This would be a calculator FRQ. It is number 2. Numbers 1 and 2 on an FRQ are always a calculator and the rest are non. So while F of T measures in pounds per hour and T is measured in hours after the store is open. So after the store has been open for 3 hours, that's really important, for 3 hours, bananas are added to the display by employees. So we're added, there, being added at this rate. So again, at the top, customers are removing at this rate, and then after 3 hours, the employees start adding bananas back to it. So rate in this problem, rate in this problem is actually G of T, because that's the rate at which bananas are being put back. The rate out is the F of T, those are customers removing it, and both of those are in pounds per hour. And the initial amount, I don't think we actually got there yet. When a certain store opens, it has 50 pounds of bananas on the display table. So that's 50 pounds to start. All right, so all important stuff just from reading the kind of the initial setup of the problem. So if we go into the actual questions, how many pounds, so I'll highlight how many, are removed. So we want an amount that is removed during the first 2 hours. So it says underline important parts of this question. And as we learned yesterday, when you integrate a rate, you get an amount. So we want to integrate for the first 2 hours, so from 0 to 2. And we need to figure out which function. Now, if it's talking about removed, if you go back up to the top, F is talking about removed, and you can simply just write F of T. All right, so if we've already learned how to put this in our calculator, since this is a calculator problem, you would just put this in. If you haven't learned that yet, I'll discuss that with you soon. Unfortunately, I'm not there to tell you today, but we can put these in our calculators. So just set it up for now. That's actually 1 point. So this is all 1 point, and then this would all get you a second point. Okay? So integrating the rate that's being removed will get you the amount that is removed. So on to part B of this question. It says find f prime of 7. Now that's the derivative of the function f at a point. That can all be done in your calculator. You should not try to do this by hand when it's a calculator question. So this, we all should know how to remember how to do. You grab your calculator. You can pause the video at any time here and take the derivative of the function f, which is on top here, at 7. Notice it does have a trig function in it, so make sure you are in radians. So again, you could pause that. But if you do find the derivative at 7, you get negative 8.120 to 3 decimal places. Now, we need to understand a few more things. That wouldn't be enough. For this question, there's actually a lot of things you need to say. So the units for F itself were pounds per hour, right? So if you take the derivative of that, think about velocity in meters per second. When you take the derivative of that, it becomes acceleration, meters per second squared. The time unit gets squared. So this is going to be pounds per hour, pounds per square hour. Okay, so use the prompt below to interpret the meaning. So that's really important. So what does f prime of 7 even mean? So you're taking the derivative of the rate that bananas are being removed, right? So, excuse me, the rate at which bananas are being removed, because we're talking about f, from the table, is now either increasing or decreasing. So we took the derivative and we got negative 8.120. So that would be decreasing because our derivative was negative by 8.120. And this time you don't write the negative because the decreasing takes care of the fact that that is negative. And then we've got pounds per hour squared. At time equals, I believe we plugged in 7 and we're in hours. This complete sentence here is what you would need. You need all these different things. The rate at which bananas are being removed is decreasing at this number with this unit at this time. That's all stuff that you need for the AP exam to get full credit for everything. So that's explaining the meaning of that in the context of the problem. You need all this. So what's happening, at what rate, with what units, at what time. All right, on to part C. Is the number of pounds of bananas increasing or decreasing? So we want to know, is the amount of bananas going up or down at time 5? So hard to figure this one out. You do not do any integration. You don't try to figure out the amount of bananas on the table because you would just find a number that says 20. But how do you know if that is going up or down? Some might say, oh, try a number next to it, but how close can you get to 20? 19.9, is that close enough? Or do you have to get closer? So it's not an efficient way of doing it. What we do instead is we look at the rates. If the rate being removed is higher than the rate being added, well then more being removed than being added, so that means it's decreasing. And so how we're going to do that is plug in 5 into each of the rates to figure out just what the rates are. And you can pause it if you'd like to go ahead and do that now, but plugging in 5 into the F equation, you get 13.796, and 5 into the other equation is 11.533. So what you can then conclude is that F's rate is higher. And remember, F is being removed. So what we say is the number of bananas is decreasing. And that's great to know, but you need to explain how you know that. Because F of 5 is simply greater than G of 5 is probably one of the easiest ways of saying that. So another way of saying that is if you did F of 5 minus G of 5, well, if that's greater than 0, same thing. So different ways of saying the same thing. All right. Oops. All of that is actually supposed to be right up there. I took the wrong thing there, but that's okay. So, looking at part D now. Part D says how many total pounds of bananas are on the table at time 8. So if you want how many, which is the word that I would concentrate on this one. How many? Well, that's an amount. So if you want an amount, we looked at this yesterday. You need your starting plus what's being added minus what's being subtracted. All right. So on the very first page, we saw that there are 50 pounds of bananas to start. Now, if you want to add, that's what the customer or the employees are added. But very, very sneaky is it says at time 3. So at 3 hours, they actually start adding. And we're going to go to time 8 because that's what they asked for. And that's G of T. But then we have to subtract what's being removed. And they start removing right off the bat. So, and that's F of T. So that's the initial setup. That'll get you a lot of points. At this point, you would actually have to plug these into your calculator, which is a lot of calculator work. And again, if you don't know how to do a definite integral in your calculator yet, you can hold off with that. That's the majority of the points anyway. But if you did plug it in, you would have 23.347, and this would be in pounds, because if you integrate pounds per hour, you just get pounds. So we had 50 pounds. You integrated this pounds per hour and this pounds per hour, and so you're going to get pounds. So 50 plus some pounds minus some pounds, and you end up with this. So that's the total amount of bananas on the table at time 8. So if you're curious, here is actually the grading rubric. So if you were following along, part A, the integral setup is actually 1 point, and the answer is the other. So plugging it in your calculator is 1 point. Part B, doing f prime of 7, just getting a number, that's 1 point. The whole meaning of it, with all those little pieces I said that you needed, was a 2nd point. On part C, that was figuring out if the number of bananas was increasing or decreasing at time 5. You have to find both those rates, and then just explain that it's decreasing for some reason. And in this case, they said that the rate being added minus the rate being removed was negative. So that means f of 5 was bigger. All right, and then lastly, you get 2 points for the integral setup here, which we had in part D there, and then 1 point for the answer. All right, so at this point, start working on some FRQ questions. Go through and do a lot of the setup first. Don't worry about it if you can't plug it in your calculator just yet. The setup is actually worth either just as much or more